And we are back. So we have Alfonso, aka Poncho, and he will talk about taming your data networks with the power of NetDevOps. So, Alfonso, take the stage and teach us about this.
Right, absolutely. Hello, everybody. Please allow me to properly share my presentation. Okay. So my name is Alfonso, and I'm a software consulting engineer here in the Cisco Lisbon team dedicated to software and automation. And today I'm very happy to be able to share with you this very interesting topic, which is some sort of a different flavor of the DevOps that we use on our daily basis. This is a DevOps devoted to the management of big data networks. These data networks that are the backbone of today's IT infrastructure. I'm talking about routers, switchers, load balancers, and so on and so on, right? So before starting, well, just to rephrase it, this is a photo that I love to share of me. It's I was visiting the Cisco office in Tokyo, Japan. And well, if you're interested in following up with me after this session, we can have a chat on my GitHub and GitLab profiles and also on LinkedIn. I will be more than happy to answer any questions that you may have. So before we formally begin, I want to share with you a horror story, which unfortunately, I'm pretty certain that will ring the bell with some of you here in the audience, especially for those who are network administrators in your company, in your business, whatever it is. So we have this company, right? It's Acme company, whatever it is. And they have this big data network. It's really complicated to pinpoint what's going on in there, but they need to update some configurations on these routers, the switches here and there, because they want to integrate a new site. So let's say that, I don't know, like an in-house data center was created in some region in Portugal, and we need to integrate it with the rest of the backbone, with the rest of the IT infrastructure. So yeah, we know which are the configurations that we need to push. It's going to be a little bit cumbersome. We need to identify which are the devices where we have to put this configs and this and that. But of course, we can make it happen. So in a good old-fashioned project management situation, the dates and times were aligned. They were like, okay, we're going to have a single maintenance night. And to this network engineer, this person got an Excel file. Why not, right? This person got not one, but many spreadsheets. And these spreadsheets, they have the name of the device, the configurations that this person needs to push, and so on and so on. And the thing is that you won't let me lie, people here who are network administrators. How do you push configurations normally in your devices? You open up a console, you connect to your devices via SSH, Telnet, whatever it is, and then you start copying and pasting. Copy, paste, copy, paste, copy, paste all the night long. You have to go through all these different spreadsheets, copying and pasting these configurations, committing, saving, and at some point, it just becomes a repetitive task, right? You can do it in a zombie mode. So that night, with this this company, this network engineer, that's what he did. Just copying and pasting all these configurations, and everybody thought that things were okay, right? They wrapped it up. We're good. Let's go home. But little did they know, the storm that was coming after them the morning after. Tickets, tickets pouring like rain, tickets coming out of everywhere. Things that were working, they were not working anymore. There were dirty configurations. There were things that shouldn't be there. There were links that were being shut down, and there were parts of the network which were actually not working after after this maintenance window, right? So of course they called a war room. They were like, okay, we need to fix this because our network, this is the backbone of our IT infrastructure. It cannot simply be down. We're losing money. we're losing connectivity. This just cannot be. And well, this networking engineer and their team, they were like, okay, well, guess this will be another night of troubleshooting at the network rodeo. So they gathered up and they did a post-mortem of what happened that night. And they found out a couple of interesting things when they started analyzing this, with a cold head. First of all, these configurations, they knew that they were working because they had used them before, but they didn't even bother to test. They were like, oh yeah, this worked on the last migration, this worked in the last deployment. There's this person here, our guru of the networking, and he said that it's going to be just fine, right? But the thing is that there was no testing. They were relying on somebody else's word. And then they had, which was their source of truth for these configurations? It was the spreadsheets. It was different files scattered all around with no correlation between them. So, but the cherry on top here was that the person who applied these configurations did nothing but copying and pasting, right? Human errors, they can have a massive impact in the status of our network. So the team gathered up and they were like, okay, we need to fix this, but we need to prevent this from happening again. What can we do about it? And that's where they began exploring this quote unquote, this revolutionary way of addressing our networks, which is NetDevOps. And that's what we'll be talking about in this session. We're going to have a look at today's network provisioning panorama. Then we will explore in depth, which are what I like to call the NetDevOps mantras, like this different flavor of DevOps. What is it about? We'll have a dash of model-driven programmability. It's important for us to know how to manage our modern era networks with the power of programmability. Then we'll have a look at some interesting tooling for accomplishing this, which is infrastructure as code, or IAC. Then we'll go on with a really nice demo, best practices, and references. So this session will be about the one-on-one on NetDevOps all in all, the tooling, best practices, and whatnot, along with some use cases, code, and demos. What we will not go in depth, though, it's networking in general or networking protocols in depth. That is something out of our scope for now. But if you're curious about it, please feel to reach out to me at the end of the session. So now, without further ado, today's network provisioning panorama. We're still bound to these common errors that have been there for generations and generations on end. Like data networks, the backbone of our IT infrastructure, has been here for quite a while, for quite a good amount of decades, right? And we're still falling through the same slips. We're still falling in the same gaps. What tends to go wrong here when we are provisioning apart a couple of devices or lots of devices of our network? We're prone to massive configurations errors, human errors, copying and pasting, putting things where they shouldn't be, because these devices may be similar, they may have similar names and whatnot. But the human errors here, it's something that really causes a lot of delay and a lot of trouble when troubleshooting. Also, we don't have a good understanding on the monitoring and consistency across the different parts of our network. When networks are so big, it's really hard to keep track on what's in there and what needs to be there. And last but not least, integrating our networks with the business, integrating them with other tools that are not networky as such, right? Integrating them with our point of sales, integrating them with, I don't know, our databases, our customer loyalty, whatever it is, things that have impact on our networks when, for example, we are provisioning a service. It's very hard to do that with the classic methods in our networks. And just to put some numbers in here, these are the current challenges that we face when we are provisioning our networks. Still nowadays, 95% of the changes are being done manually in our data networks. And 70% of the issues that we find on a day-to-day basis, they're caused because at some point at night, somebody copied and pasted the configuration in the wrong device, for example. It's human errors, right? Honest mistakes. And 75% of the operational expenses are actually invested on troubleshooting and visibility of these networks. So these numbers don't lie. There's something that really needs to change. And that's why many companies are aligning themselves to this state of mind, to this culture of NetDevOps. So to give you a little bit of context of this different flavor, of this specific flavor of the DevOps culture, the DevOps state of mind, I want to talk to you why networks are a different kind of creature. They're a different kind of Pokemon, so to say, right? Let's dynamic apps, the apps that we all use, the apps that are like a consumer front faced. These apps, they are dynamic in the sense of we can host them anywhere we want, right? And nowadays, it's more and more easier to have all sorts of deployments. Maybe I want to have a portion of my app or some components of my app in-house, or I want to have some on my cloud. I want to opt for a hybrid deployment. My app is virtual machine based, it is container based, and I can orchestrate all the components by following these trends, right? It gets easier and easier all the time. That's where all the evolution is going, right? It's very, very fast paced. However, on the other side, the networks, which again, I can't insist enough, are the backbone of our IT infrastructure. They are not that they're not that fast, right? Like their pace is not that fast because of the nature of a network. A network by nature, it's tightly coupled, one component to the next and to the next and to the next, right? And because of that, the maintenance is often done manually. And the access methods that we have for interacting with these machines, like how do I talk to this router, to this switch, to this box, whatever it is, it was made, it was intended from its inception to be human friendly, to be exclusive for humans. Like for those here in the audience who have logged in into a device via CLI, an SSH or a Telnet console, whatever it is, when you type commands, these commands are intended for humans. They're not intended to be consumed, for example, through the point of an API, right? Or at least that's how things were done traditionally. So now taking that and trying to align it with the DevOps state of mind, the ultimate purpose here, or these like 3 steps, which I like to call the NetDevOps mantras, it's first of all, I want to be able to achieve the desired state of a network with minimum manual intervention. I don't want to need to copy and paste to be able to achieve this desired state in my network. Then I want to make sure that the current state aligns with the desired state. How it's going to happen, well, we'll figure that out later, but I want it to be aligned at all points, right? I want it to be aligned always. That's very important. And last but not least, I don't want to have scattered sources of truth. I want to have a single, consistent source of truth for this desired state that I want in my network, right? And aligned to this, we have this topic, with this new topic, which has been gaining traction in the industry recently, which is infrastructure as code. How do I materialize my NetDevOps mantras? Well, I can use infrastructure as code for that, which basically means that I consider this desired state of my network as nothing but code. Code and code only. No spreadsheets, no loose post-its, no whatever it is. I want to treat it as code, and so that we can follow this DevOps approach, this DevOps state of mind. And here there's some alignments, like the foundation pillars of infrastructure as code, which is my configurations are not text to copy and paste. This is code, which is versioned and maintained on a VCS or a version control system, which it's a Git, whatever flavor it is, but it's a Git at the end of the day. And I want to treat it under a software development mindset, right? If I want to add new configurations to this desired state of my network, I shall treat it as code, following a branching approach, whatever it is, but as code always, right? And last but not least, something very important about infrastructure as code. If there is some commit, if there are some configurations which were applied in my network that were faulty, my tooling should be clever enough to be able to roll back right away. So these are also some sort of infrastructure as code mantras, the foundation pillars, and it's very important for what we're going to see next. So let's take this concept of NetDevOps and infrastructure as code and put it together in something familiar for all of us, which would be a pipeline, right? A CI/CD pipeline. This is how it would classically look, right? This is how it would normally look from code to Corral. We have our business requirements, which is this desired state in my network. Maybe I need to add some more features. I need to turn on some interfaces. I need to create some access control lists to block some IP addresses, whatever it is. That is discussed, planned, and written in stone. Then this goes to our network engineer, the person who knows about the network, the nooks and crannies of this configuration, our guru, so to say. Then this person will create the definitions of this desired state in human-friendly formats, which would be YAML file or a JSON file, something that it's easy to follow, that makes sense for everybody, and that it's easily versionable and maintained in our Git or whatever it is. And once these changes are done in our desired state, they go through our Git, and that's where we trigger our pipeline. What will happen in this pipeline? Well, our infrastructure as code tooling, maintained by our NetDevOps engineer, will take these configurations, will translate them into actual configs that will later be pushed into our network devices by using network controllers. Which network controllers? Well, it depends on the kind of network, the kind of devices that we're talking about, okay? And now just to put it into more like a pipeline and stage visualization, this is a very generic approach, but it's a very good starting point when it comes to NetDevOps. So we have on this corner our ticketing, our sprint planning, our IT governance, whatever it is, right? And from here, we have our user stories. Like, I don't know, in our desired state of the network, I want to add a couple more access control lists. We want to be able to block some remote IP addresses in my data center, whatever it is. So that is planned. Then we create a staging branch for the development of these features. Our configuration inventory is updated with these features. It is linted, of course. We want to have only valid configurations. And then we spin up a staging environment, right? When we talk about normal apps, like a mobile app or whatever it is, this concept makes a lot of sense because we can spin a container with our host OS, a specific OS, specific libraries, Python, Java, whatever it is, like all those requirements, it's very easy to spin that up, right? It's ephemeral, it's our test container. We test there, all tests pass with flying colors, that's it, we go home. However, in the data networks universe, that's a little bit more complicated because it is not the same to create a staging environment for an app than for an entire network. It's way more cumbersome. Networks, as I mentioned before, they are like these strange creatures and they have these strange considerations. There are some tools out there which help us to do this, though. There are some tools that help us to create a digital twin or as similar as possible to what we have in the production network. We can spin it up in a container fashion, and we can have all these different network virtual devices connected in between, like creating a whole network. And we can use that for proper testing. It is testing as accurate as possible, mimicking what we have in production. So we can make that happen. There's these tools like NetSim, Verl, CML, a couple more. Once we spin that up, we test the changes in our configuration inventory in this digital twin, and we run the series of tests, right? Like if they pass with flying colors, all of them, we can create an artifact with the reports of these tests, and then we move on from the staging branch to the production branch. Through a PR, for example, we can merge these changes in our inventory, configuration inventory, where we have the desired state of the network. And once that PR is approved and our changes go into the main branch or develop branch, however you want to name it, we are in conditions to applying these changes in our production network, the real deal, right? It's very important to be able to first do a dry run, because our simulation environment may not be as accurate as it needed. So it's always good to be able to do some last minute checks. And if everything looks fine, we should be able to finally commit and test these changes once again in production. Once it's all good, we create an artifact with our reports of the tests, and then we just wipe out all the resources that we created for making this possible, like containers, our stage environment, whatever it is, right? So this is like more like a generic approach, but it's for us to know, like on real life, which are the most common stages of a NetDevOps environment. And now I want to go to this specific part of this structure and talk about how do we communicate with our devices. Because as I mentioned before, just copying and pasting commands on an SSH, on a telnet interface, that's not good. That won't work on a mass scale environment. That will definitely not be compatible with the NetDevOps environment, because these tools, the CLI, SSH, telnet, that's intended for humans, right? Machines cannot talk in between them using CLI commands. That just doesn't work. So that's why this is a trend that has been ongoing with the main network vendors, which is model-driven programmability. What I do here is that I define all the different elements within my network box, within my switch, within my router. I define them with code. I describe this structure using a very specific modeling language, which is called Yang. And this Yang is standardized, and so that all companies, all vendors, their network devices can talk in between each other, right? And there's many different kinds of models, Yang models. There's models for the data that we can have in our devices. There's models for the services that we can have. Like for some here who know about networking protocols, there's models for how my OSPF should like, for how my EIE RGP should look like, and this and that. And there's also standards. There's industry standards, which are properly regulated by the IETF, by the Internet Engineering Task Force. And there are also some vendor-specific standards that are exclusive for Huawei, Nokia, Cisco, whatever it is. And just to show you how does this look, let me share with you a hint of these models. For example, I have here one of the models publicly available out there, which is for defining an access control list on an iOS XR device, right? So you can see here this Yang modeling language. It looks a little bit like JSON, so to say. But here, the important part is that we're able to describe how my components look like. So here I have this container, which is an ACL and prefix list, right? And here I have access list manager, prefixes, sequences, name, access. You can see here that this is nothing but the description of how does an access control list look like, right? And this is going to be very important for what we are about to see. Okay, let me go back to our slides. There we go. And there are some standard protocols that we can use that are entirely based on this modeling language. And we can use them for allowing our devices to communicate in between each other, but also for other parties, such as, for example, our pipeline, our CICD pipeline, to communicate with our devices. The first one is netconf. netconf is based on SSH, like there's an SSH session underneath, but what we use with this one is RPCs, or remote procedure calls, to be able to communicate in between devices or in between my pipeline and my device. And there's a very specific set of commands, of operations that we can use for this. Here I have a couple of these. For example, edit configuration. Hey, I want to change this. I want to delete this configuration. I want to get this specific data from your configs. But the thing here is that they are entirely based on a Yang model. If, for example, I want to create a new access control list, I need to first know how does an access control list model looks like. And that's the file that we just saw in the Git in my browser. Once I understand how it looks, I can create this payload using these instructions, and it's a XML format, and then I can send them via SSH to my devices. So this is takeaways here, SSH-based and entirely based on Yang models, okay? And now we have RESTconf. If the REST part rings the bell, yes, that's because it's based on REST API fashion. We use the exact same verbs that we have for REST, get, post, put, patch, delete, whatever it is, in order to communicate with our devices. This is entirely HTTP based, which means that I can talk with my devices as if they were an API point, right? As if they were a REST API endpoint. It's as simple as that. Yet again, the payload that I send on these requests is entirely based on this Yang data model. So I also need to know, how does this access control list look before I create my payload and send it to my device? It can be via, the payload can take the shape of JSON, of XML, and then the replies that I get back, exact same thing as our REST endpoints, right? I can get a 404, I can get a 200, a 201, whatever it is. It works in a very similar fashion, and that's good, because for people who are used to working with REST API endpoints, well, this is piece of cake, right? And just for giving you an example, this is how a request would look. It's pretty much my URL, which represents my device, because there inside we have the RESTconf endpoint. It's something pretty straightforward. And now I want to jump into the tooling, right? Because these are the ways in which we can talk to our network devices. But now, how can we enable that communication? How can we enable our pipeline to be able to manage through all this life cycle of our desired state in the network? So for that, we have infrastructure as code tooling. And there are two different kinds, declarative and imperative. Declarative here, we have the definition of what. What do I want to do? And the tool is clever enough to determine which are the steps, right? We don't really need to worry about what's happening in the background, because it will sort it out altogether for us, right? For example, if I say that I want to create an ACL, my tooling, which is declarative, will know that an ACL requires first to create this, then to create this, then to create this in this order, and I don't have to worry about it. So the pros on this, it's way easier. I don't have to worry about the details. I don't have to worry about the nooks and crannies of this. However, the tooling that we have is very specific. Like, I can create an access control list and an access control list only, right? There's no flexibility. If I want to tweak something here, something like that, a little bit more specific, I don't have that flexibility, right? And a prime example of this sort of tooling, it's a Terraform. Although Terraform is mostly used for infrastructure in the cloud, to spinning up and managing the lifecycle of AWS, Azure, whatsoever instances. It is also widely used for network devices. And it all comes to this. In Terraform, we have two different files. It's our provider, which is the devices or the endpoints, the resources, that we're going to be connecting to. And then we have what we want to do with them. In this case, for example, I want to create an access list. And here I have the definition of which is my target device, which are the parameters of this access list. It's all in these files. Then we have our provider. And this provider, it will take these files, it will run the calculations of which are the configurations that it needs to push. Then it will finally commit them into our destination device. And the vendors that we can cover, the things that we can do, it really depends on the plugins that are available. There are specific plugins for example, a Cisco IOSXR device, and a specific plugin for creating access control lists on this specific device. It all really depends on what's in there published by the vendor, but once it's done, we can use it pretty easily. And that's why Terraform is one of the preferred tools out there in the networking world. And then we have the imperative ones. In imperative, with imperative tooling, we need to define how. Like if I want to create an access control list, I need to first do this, then do this, and then do that, right? Like these commands, they have to be executed in a specific order. And also the error handling rollback, we need to cater for that ourselves, right? Like we need to put something up front in order to control all these nuances, right? And the drawbacks of this certainly is that it's way more work, and you need to be more aware of what's happening there behind the curtains. However, you are more enabled to do different things. You have more flexibility. In case you want to cover some corner cases, for example, or you want to do something very specific with this tooling, you can do it. And here I have these two examples, which is Ansible and NSO. Half and half, I was mentioning, because they're a little bit declarative, they're a little bit imperative, they're somewhere in the sweet spot, right? For Ansible, it's in a nutshell, we need to have our inventory file, which is our target endpoints. And then we have our modules, which is basically like the plugins in Terraform. How are we going to be talking to our devices? How many things we can do? And we put them all together on a playbook. And this playbook is the set of instructions of these configurations of this desired state that I want to have in my network device. And then Ansible will determine all these configurations and will push them in the device for you. Bear in mind that when we work with Ansible, we need to have an Ansible agent installed inside of our devices. Most of the vendors support it. It's commonly used as a sort of standard in the industry, but it's just bear in mind that we have a small living agent of Ansible there inside my router, my switch, whatever it is, right? And just to make a comparison here, if we have an imperative approach with Ansible, it's basically, I don't know, I can send my configurations, I can send my CLI against having a proper module in a declarative fashion in which I have this specific module used for specific ACLs on my IOSXR devices, for example, and I can send these configurations. It depends on what we want to do, and also the modules that are available out there by the vendors, right? And then finally, I want to mention one other option, which is a cross-work network services orchestrator, or NSO. This is more like a framework, right? On the top, we have an integration with business logic. We can create, using yet again Yang, using data models, we can create services that we expose to our third parties, to our pipeline, whatever it is. And then we can have Python or Java code to take these inputs, work with them, and then push configurations southbound, which is to our devices. Here we have something that is called a network element driver, or a NED. These are some sort of plugins that we can get from different vendors so that we can talk with these different machines, with the different routers, switches, whatnot, using different protocols. For example, I can talk with a Fortinet via CLI. I can talk with an IOSXR via NetConf. I can talk with a Huawei via RESTConf, right? It depends on what we need to do. We can get these different small plugins, right? And now, speaking of which, the demo that I want to share with you, it's based on the latter, cross-work network services orchestrator, and it is a NetDevOps pipeline for provisioning ACLs, access control lists, on my devices. How it looks? Well, this is a layout. It's entirely based on GitLab. GitLab is our VCS and also our CI/CD engine. We have our service code. We created a service for putting these configurations from our inventory into our devices. We have this inventory, these configuration files, and we have some tests made with Robot Framework. And we're going to have a staging environment. In this staging environment, we spin up an NSO container. We spin up a dummy network based on this tooling, which is called NetSync. And we install these plugins for talking with the devices, right? Like the required nets. We apply the changes here. We convert our inventory in YAML. We convert it to JSON, and we push it into our devices using RESTconf, right? You remember RESTconf. And if it all passes with flying colors, we create an artifact with the reports of our tests, and then we bring that into our production environment if we do a PR against our main branch. That's how it works. Let me switch now that. Okay, I will share with you the link later. This is a repo open for everybody if you want to have a look. This is my demo based on NSO. I want you to have a look at this inventory. And here we have my access list router RFS. You can see that here we have, here we have YAML format. And we're talking about a device which has two access lists, test ACL1, test ACL2. And here we have some different parameters, right? This is YAML. This is an inventory. This is the desired state of my network. I want my network to have this configuration at all times, okay? And with this pipeline, we're able to accomplish this. So here you see that I have two runs of my pipeline. This is my day 0 configuration, which means that this has the complete configurations, right? Let me show you here the pipeline. This is what's happening in a nutshell. I am taking this file here. I am doing some linting. I want to have a healthy YAML file before working with it. So I lint it. Well, first of all, I install my libraries, my Python libraries, whatnot that I will require later. And then I lint my inventory. If it's properly linted, if it passes with flying colors, then I spin up my staging environment, which is my NSO container, my packages, and my test bed. This is where I spin up my dummy network so I can test my inventory. Then I run my tests. These are very basic robot framework tests. And if it all goes well, we are in the main branch, which means that I connect to my remote device, to my remote server, and I apply these configurations to my production network, right? Those configurations are there already in production. And for example, if I want to add something to this inventory, I have here this PR with this other branch. You can see here that my changes were that I added 2 more entries to my inventory. These are 2 more access control lists. I also updated my tests, of course. And you can see here that the pipeline looks a little bit different. It is not the main branch, which means that I am just going to test them, right? I'm just going to test these configurations. Once this PR is approved, I will push them with this extra stage, which is deploy, into my production network. And the thing about this is that, last but not least, we have our artifacts. And you can see here that I can download the results of my tests. I already downloaded one here, and I have this very handy HTML report. And here I can see that all my tests passed, that I pushed my configurations. You can see it here. I used the patch and using RESTconf, right? And what did I get? 204, which means we're good. Okay? So in a nutshell, this is how this NetDevOps, in a very, very simple approach, of course, but this is the intention, that I want to convert my desired state of the network into actual configurations that are pushed by my CI/CD pipeline. Okay? Let me go back just to wrap it up here very quickly. Just common practices here. For all the people out there who are interested on embracing these practices as part of the day-to-day in network administration, I know that it sounds a little bit intimidating, right? Because we have this conception that if you want something to be done properly, you should do it yourself, or like there should be like somebody, like a human being behind the keyboard doing these things. When we talk about the networking universe, right, which is so delicate and so tightly coupled. So my advice here, and that's what I always tell to my customers, is to start small. It is very, very possible and very easy to just automate a little bit of my day-to-day in network administration. There's some slightly, some small repetitive task, some day-to-day provisioning. It's very easy to do. It's very simple to do. All the tools are out there. All the information is out there. Most of it is open source. So it's just this invitation to embrace this NetDevOps state of mind little by little, and just to take it from there, right? It's an open invitation. And also, don't forget about your network engineers. They always come handy, because you cannot automate something that you don't fully understand. That's the truth, right? Yes, we have this DevOps approach. Yes, we have this software lifecycle approach. But at the end of the day, we're automating data networks, the backbone of our IT infrastructure. So it's always important to have onboarded our networking gurus so that they can sort out all the corner cases, all the things that look sketchy, and have a proper, consistent configuration file for our desired state of the network. And then commit frequently, but never to main. Always embrace the PR lifestyle. That's my best advice. And keep your tests small and clear as possible, as atomic as possible, and be merciless. All tests must pass. Nobody wants to wake up to lots of data tickets, right? And I will leave here with you some references, some lectures that I find very interesting if you want to get involved into the infrastructure as code, NetDevOps and whatnot universe, also a little bit of network programmability. If you want to have a look at my GitLab demo, this is the link. And that would be it from my side. I want to thank each and every one of you. And I think we are right on time for questions. The market is all yours.
That was awesome. I wish I had this about 10 years ago when I was working with automation on data centers, on-prem data centers. Right? Really awesome. We have 3 questions. Yeah, I'm honest on that. We have 3 questions. This question was one was in the beginning of the presentation, maybe could already be answered. Here are the questions. It was that each environment usually go to testing to have testing environments for network. How you can achieve testing? This keep a full copy of your infrastructure in simulator, and that is any rollback plan when applied configuration.
Yeah, exactly. Okay, let me go one by one. I have the questions here. So branch probably tested a mock-up environment, test environments for a network. Yeah. Okay, yeah, testing. First, I want to start with testing. It really depends on what you want to do, because there are different ways to test how the impact of the configurations that we apply on a network, right? On a virtual network, dummy network, whatever it is. So the first one that engineers normally use is to compare configurations. Like, I applied this, and then I go back to my device and I read the configurations, and I know beforehand what's going to be the impact. So I read all these configurations that I get from the device, and I check if the changes are there, right? There's different ways of contrasting this. Some people do just bare text-to-text comparing, and if text A matches text B, that's good. We're good to go, right? There are some other, we can do that, for example, with robot. That's exactly what I did. I was just on my robot test there. I just compared, I read the device, I got the configurations, I compared it against what I was expecting, string match, we're good, right? There are more complex mechanisms, and there's tooling for that. I would recommend PyATS. I can share with you the information later. PyATS actually takes a snapshot of not only my device, but also the devices around it. so that I can really analyze the impact. Because, for example, if I want to create a new routing protocol, right, like an OSPF, and all these other devices are now neighbors, I want to know that they are neighbors, right? So there's other tooling that goes beyond that. It's like network state snapshots, and we can compare them and also know if tick or cross, right? Now, for full copy of infrastructure in simulator, that's desirable. Yes, that is desirable, but there's also techniques for doing that. We can maybe work with a specific segment of the network, and I only have the configuration backup of that specific segment, right? Because of course we don't want a file that is like gigabit long, right? We want to keep it simple. Our Git platforms start doing strange things with large files, so we can keep it small and segmented. And then finally, a rollback plan when applying configuration. Yes, all infrastructure as code tooling, they have some sort of rollback mechanism, right? Without going further into details, the three main ones, which is Terraform, Ansible, and NSO, they do have their own rollback. So you can control under which situations you can trigger the rollback, but more than often the device tells you, right? Like if you're putting any configuration that makes no sense on a device, on a router, whatever it is, the device will complain. The device will be like, I couldn't do this. And then these tools are clever enough to go like, oh, okay, I can roll back, right? So it depends on which tool you're using, but they can all do it. Right.
I have one next question from. So, when the configuration is wrong, but when the configuration is applied, the effect of the you're applying can have effect, negative effect. So there are any techniques to act like to validate to how do you can check this if it's possible? It's working. You apply your Terraform or whatever tooling, and it's working. You made the but what we applied can have a performance or even destroy something that's supposed to be destroyed. How you can avoid the situation?
Yeah, of course, nobody wants to mess up, to destroy anything on a production network, right? Most of these tools, they have the concept of dry run. The dry run, it's something very, very common in the networking world, because again, these configurations, they are so delicate that we really want to understand what's going to happen if we push this without actually pushing it. So yeah, we can issue dry runs of the configuration that we're about to push, and we can evaluate the impact, right? That's something that we can do. But well, before that, also having a reliable simulated environment comes handy, because sometimes the dry run won't tell us the whole truth, right? Especially when these are configurations that propagate to the neighboring devices.
Okay. Any more questions? I think we are almost in the time. So thank you for your. So yeah. So thank you. Have a good. Bye.
Thank you, Edison. Thank you.